Okay, good afternoon, everybody. All right, so we're working through the expansions notebook currently. So we've seen brace expansion. We looked at that in the last lecture. We've seen tilde expansion previously. Right, so remember in tilde expansion, the tilde character expands to the name of your home directory, right, or of the current user's home directory. So if I print the value of tilde, you get root home Burton on my particular computer, right? On your computer, you'll get a different value. If there's multiple users on your system, then tilde followed by the username expands to the absolute path of that user's home directory. Right, so if there was a user sys220 on this computer, I don't think there is. Oh, there isn't. So if there's a user Homer Simpson on my computer, which there is, I think, right, that expands to that user's home directory name. Right. As you just saw, if you type in tilde unknown, so a username that doesn't exist, right? Oops, sorry. Then the expansion never happens, right? All that happens is that you get the value of, you get the literal string tilde unknown user. All right, so tilde expansion is not that useful, right? Well, it's not that interesting. It's not very complicated. Tilde expands to the current user's the absolute path name of the current user's home directory. Parameter expansion needs an entire notebook of its own, and more, actually. So when we get to that particular notebook, we'll talk about parameter expansion. Parameter expansion is what you have to do when you start working with variables. Okay, so command substitution lets you run a command, and it lets you replace the command itself, right? So you take the output of the command, and the output of the command replaces the command itself. So a command substitution looks like that. So it starts with $, then there's some parentheses, round brackets, and then there is the command with whatever options and arguments you want to use to run the command. Right? That entire expression there gets replaced with whatever the command, when it's run, with whatever output the command generates. Right? So the command gets run in what's called a subshell. So your shell starts a new shell, runs the command in that new shell, takes the standard output of the command, and replaces all of this with whatever the command produced on standard output. Often when you do this, you're going to take whatever the command produced and store it in a variable somewhere. Right? But we'll come back to that when we talk about parameter expansion. Here's a little example of using a command substitution. Again, if you're on a Mac, this may or may not work for you because the date command behaves differently on Mac compared to Linux. So let's look at what date plus %a does on my computer. Okay, so first of all, remember what date does. It prints out the date, the current time, and date. So date date plus %a. Prints out just the day without an abbreviation, right? So it prints out the word Monday. And date plus %h colon %m. Like that. Right, not surprisingly, that prints out the hour and the minute. Right, again, notice on my computer the time is wrong, but never mind. Right, so if you wanted to print out today is Monday, comma, it's whatever time it is, right, you could use a pair of command substitutions here to do that. Right, so remember, if you just run date on its own, if you run date %a, date plus %a, right? You want to run that as a command. The problem is this is inside of a string, right? So it's inside the string, today is blah, 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 right? I don't want the string date plus %a, I want the output of date plus %a. Right? So if it's the output that you want, that's when you want to use a command substitution. Right? So when I run that, you get today is Monday, it's 1319. Right? And so what's happened here is, the command here gets run, right? Whatever output it generates replaces all of that, right? And so Monday replaces everything that's highlighted up here, right? The date that command right there runs, right? Whatever output it generates replaces all of that, right? And so that's the 1319 that's right there, right? And the command substitutions happen before the echo command is run, right? So when the shell sees this, when the shell sees this command with this argument, right? It reads the argument, notices that there's a command substitution here, so it performs the command substitution, right? It sees a command substitution here, so it performs that command substitution, right? Then it gets that entire string, and that entire string gets passed to echo. Right, so once again, you see that an expansion or a substitution simply replaces the expansion or substitution with the result. Right. So here's an example of saving the output of a command to a variable. Right, so bash has variables. They are, all bash variables are strings. Right, so I guess that's useful to know right now. Right, even things that look like integers are actually strings under the hood. Right? So everything's a string in bash. Here I'm creating a variable called moo. You don't have to declare the type because everything's a string. Right? The first time you use a variable, the variable gets created for you. Right? So this makes a variable moo. Right? We're going to assign it the value of something. The something that you're going to assign it the value of, in this case, is a command substitution. Right? So once again, right? When bash sees the command substitution, it runs the command, right? Grabs the output of that command, and the output replaces all of that. Right? So this is an assignment, so that means nothing gets sent to standard output. So I just ran that, nothing appears. Right? So there is no output generated here, it's just a variable assignment. Right? But there is a variable somewhere called moo, and the contents of moo is whatever the output that cowsay generated. Right? So if I now print the variable moo, you get the output from the previous command, right? Notice that when you access the value of the variable moo, right, you use a $sign in front of the variable. Strange, but that's the way it works in bash, right? So assignment to a variable, right? You just write the variable name equals something. When you want to use the value of the variable, right, it's $sign, name of the variable. Right? That $sign name of a variable is a variable substitution or parameter substitution. And we'll talk more about that in a later notebook. Okay, what about arithmetic? So your shell, bash can do integer arithmetic. It cannot do floating point arithmetic. Right? If you want to do floating point arithmetic, you have to call another command that knows how to do the floating point arithmetic. Right, but the shell itself can't do floating point arithmetic. So all that you can do is integer arithmetic. Right. Oh, there's a missing bracket. Drat. Sorry. Okay, so if you want to do arithmetic, then you can do arithmetic inside of what's called an arithmetic expansion or an arithmetic substitution. Right? The form of an arithmetic expansion looks a lot like a command substitution. Right? The only difference is there's 2 round brackets instead of 1. Right? So $, round bracket, closing round bracket, some sort of arithmetic expression in between, right? Where the expression is some sort of integer arithmetic expression. Right? You have all of the normal operators that you see in most programming languages, so adds, addition, subtraction, division, multiplication. Is it here somewhere? You also get remainder, so the %sign, just like in Java, and you get exponentiation as well in bash. So exponentiation in bash is the double star, I believe, if I remember correctly. We'll check that in a second. Right? Okay, so there's an example of an arithmetic expansion. Right? So double $sign, round bracket, indicates to the shell that this is an arithmetic expansion. So it tries to perform arithmetic on the stuff inside the round brackets. Right, 1 plus 1 is 2, so this should print 2, which it does. Right, if you don't include the round brackets, right, so if you just write that, the shell can't compute. The shell doesn't compute that as though it were an arithmetic expression. Right, it just treats it as though it were a sequence of characters or a string. Actually, it treats this as 3 characters. So it doesn't do anything with this. It doesn't perform any arithmetic with this. Right? So dollar, round bracket, round bracket, round bracket, round bracket. Right? I'm pretty sure exponentiation is the double star. Yes, it is. Right? So double star, so 10 raised to the power 3. Right? You also get division. Right? Division is truncating division, right? So similar to Java. So 10 divided by 3 is 3 point something. You get rid of the point something and you're left over with the 3. You also get the remainder operator, right? So 10 divided by 3 is 3 and a bit, right? The remainder is 1, right? And so you get 1 in this case, right? So you also have the remainder. It's very uncommon. Well, it's pretty uncommon to do arithmetic when you're working on the command line, right? Normally when you're working on the command line, you're normally working with text and files, right? And so it's kind of uncommon to do arithmetic directly on the command line, right? This is a silly contrived example of when you might try to do something when you might try to do arithmetic from the command line, right? So this tries to make a directory whose name starts with dir. Right? And then there's an arithmetic expansion. Right? So that thing, 2 times 5 is 10. So everything that's highlighted there gets replaced with 10. Right? And so this ends up making the directory dir10. Like there. Right? So the expansions are funny in Bash. Right? So remember that whenever you have an expansion, whatever the expansion evaluates to, everything, the rest of the entire expansion gets replaced with that text, right? And so here, right, everything that's highlighted gets replaced with 10, right, which gets joined to dir to produce the string dir10, right? And so this is not only is this an example of an arithmetic expansion, it's also string concatenation in Bash, right? There's no special operator to concatenate strings. If you want to join 2 strings together, you just write them side by side, and it automatically joins them, right? So dir is a string. This thing all evaluates to a string, right? So the 2 strings get joined together, and you end up with dir10, right? Strange but true, right? That's the way it works in Bash. Okay, so where you might see arithmetic occur is when you're starting to write a script. So when you're trying to write a little Bash program to do something, right? Then it's, I guess, a little bit more common to need arithmetic. And now the expansions become more useful. The arithmetic expansions become more useful. All right, so after all of the previous expansions have occurred, right, anything that's not inside of quotes undergoes what's called word splitting. Right, so word splitting, we've seen this already, right? So word splitting splits a string into separate parts, right? Each part is separated from the other strings or the other parts by a space, right? So spaces in Bash are important, right? They're the things that separate individual strings. After the word splitting occurs, you end up what's called a list of strings, right? So right here, right there you've got 3 separate strings, right? sys220, assignment, and solutions.zip, right? They're separated with spaces, right? And so as far as Bash is concerned, that's a list of 3 strings, right? Okay, so I'm in the directory bash scripts expansions, right? So the directory that contains the directory for this particular notebook, right? There's your file, sys assignment solutions.zip, right? So if you were to type in, so if I was to try to extract the contents of that zip file by typing in not that, but that instead, and press enter, right? So the command complains, right? The command complains it can't find sys220, it can't find sys220 zip, or sys220 all caps zip, right? And so what it's trying to do is it's trying to interpret that as the name of a zip file, right? The name of the zip file is all of that, right? But because we didn't quote this or escape the spaces, the shell thinks that this is 3 separate strings, right? And so again, the correct solution is to either quote the entire expression, right? So single quotes or double quotes works here. You can escape the spaces as well, right? And then it'll try to unzip the file. I guess this isn't actually a true zip file. No, it's just a file I made up, right? It's actually empty. So it's not an actual zip file. Okay, so by default, the space, there's something called IFS, so the internal field separator variable. That variable stores the characters that are used to perform word splitting. Right? One of the characters in that string is the space, right? Another character is the tab character, and the third character is the new line character, right? So all 3 characters are in that variable IFS by default, right? Any character that's in IFS can be used to perform word splitting, right? Because IFS is just a variable, you can redefine the value of IFS so that you can perform word splitting using a different character or characters, right? So we'll look at an example of that in just a second. The funny thing in Bash is that you kind of have to remember what order the expansions and word splitting occur in, right? So the word splitting occurs after all other expansions except for file name expansion, which always happens last, before all the other expansions occur, after all the other expansions occur, right? And so that produces weird results, or can produce weird results. So here's a variable str, right? So it's just remember all variables in Bash are strings. So this is the string field 1 followed by a bunch of spaces, right? Field 2 followed by a bunch of spaces, field 3 followed by a bunch of new line characters and possibly spaces, followed by field 4, right? So that variable, that string really does look like that, right? So if you just try to print that string like that, right, something strange happens, right? You might expect to get that, right? But what you have to remember is that word splitting occurs, right, before the command actually runs, right? So there's your parameter substitution, right? So parameter substitution causes the contents of str, all of that, not including the quotes, all of that replaces that, right? Word splitting occurs. Right? So how does word splitting work? Right? Anywhere it sees a space, right, it splits that and that into 2 separate fields. Right? The extra spaces don't matter. Right? So the fact that there's 4 spaces there doesn't matter to the shell. Right? The shell says, oh, you've got a string here and you've got a string here. So I'm going to split that and give you the string field 1 space field 2. Right? Now you've got a space here, or a bunch of spaces here, followed by field 3. Right? So now your list is field 1 space, field 2 space, field 3 space. Right? You've got a bunch of new line characters here, right, followed by a string. So the new line characters, they're part of the IFS variable. So now the shell splits field 3 and field 4. And your final string is field 1 space, field 2 space, field 3 space, field 4. Whoops, I never ran the cell up here. Okay, and now I can run that, right? And so you don't get that string there, right? You don't get that output, right? You get the result of expanding that string and then word splitting it, right? And so you just get the four strings, field 1, field 2, field 3, all separated with a space, right? If you want to keep all of that funny spacing, or all of the unusual spacing in that string, you have to stop word splitting from happening, right? The way you stop word splitting from happening is to put it inside of quotes, right? And now you get that, right? So double quotes suppresses word splitting, right? Single quotes doesn't work in this case, right? So if you single quote $str, right? Remember what single quotes does. Single quotes turns off the special meaning of everything inside the string. So the dollar sign is no longer important, right? It's just the dollar sign, right? In other words, it's not indicating, the dollar sign in this case no longer indicates that we want to access the variable of str. So you just get str, right? Right, so one more time, no quotes around str, word splitting happens, right? And you just get field 1, field 2, field 3, field 4, right? In other words, you lose all of the formatting that you might have had inside the variable. Or, you lose all of the formatting that you had, or all the spacing that you had in the value stored in the variable, right? Double quote the variable stops word splitting from happening, so it maintains all of the spacing that you had in the variable, right? Single quotes disables special meaning of all characters inside the single quotes. So now you don't even get the parameter substitution, and you just get the string $str. All right. So if you want to, it is sometimes useful to manipulate the variable ifs to cause word splitting to happen on different characters. Right? So suppose I've got someone's student number, last name, and first name stored in a file somewhere. Right? This is how OnQ imports and exports your student information. Right? So if I download your grades from OnQ, they come out in a form like this. Right? When I upload your grades to OnQ, I have to upload them in a form like this. Right? Your grades would be comma and then a comma separated list of grades here. Right? Okay, so if I would like to process this string, so for example, I would like to get out the student number or the last name or the first name, right, then it would be useful to split this string on the commas. Right? And so I can do this by manipulating IFS. Right? So I'm going to store, now remember IFS is pretty important, right, because it stores the characters that are used to do word splitting. Right? So if you change IFS, you have to remember that it's probably a good idea to change it back when you're done with it. Right. So I'm going to remember the current value of IFS. That should be space, tab, new line. I'm going to change IFS so that it's now just the comma. Right. I'm going to print out that string. Right. So when I print out that string, it's going to split the string wherever there's a comma. Right. And insert and separate the individual parts of the string with a space. So I should get, and I do, right? I get out the individual pieces of the string separated with a space instead of with a comma, right? After I'm done with the splitting, it's probably a pretty good idea to restore IFS back to its old value. Right, so why would I want to do this? Well, because I can process, you can write a loop, right? And when you write a loop, this is a for each loop in Bash, right? So if you write a for each loop in Bash, you can write the loop so that it processes a list of strings, right? If you change the word splitting character, right, I can process a list of strings that looks like that, right? In other words, a list of strings where the strings are separated with a comma, instead of a list of strings that are separated with a space, right? So there, I can loop over the elements of the string now, right? Splitting the string at the commas, right? And I can extract out the student number, the last name, and the first name in that loop, right? And of course, you can do this in a more sophisticated way so that you can, instead of using a loop, you can access the individual pieces of the string separately, right? And we'll see how to do that later on in the course. Right? Now, it turns out the exact rules for describing word splitting are fairly complicated. Right? I've only given you the basics of it, which is sufficient for this course. If you want to know the exact rules, that's the reference for it. Right? So you can click on that link there. and that'll tell you the precise rules that the shell uses to perform word splitting. Okay, so the last thing that happens is file name expansion, and we've seen that already, right? When you use a star or a question mark or a character class, right, all of those things expand to certain sequences of characters, right? Star matches any sequence of characters, question mark matches any single character, right? And the character class matches any one of the characters inside the character class, right? And so file name expansion always happens last, right? So it happens after word splitting. All right, so if you need a reminder on how that works, go back to the file name expansion notebook. All right, so there's an introduction to all of the expansions. We're now going to look at some of them anyway, in greater detail. Right. So the next notebook in the sequence is Introduction to Bash Scripting. So basically you're going to write a Bash program, right? What is a Bash program? It's just a sequence of Bash commands. You put it in a text file somewhere. Now you can run that text file as though it were its own command. Right? So a Bash shell script is just a plain text file containing a sequence of Bash commands. Right? The shell runs each command in the order that they appear in the script. Right? So it's very similar to a Python program, except the interpreter is Bash instead of Python. Right? So when you run the script, the shell just reads the contents of the file, interprets the commands contained in the script, runs them line by line. So when you write a script and you want to run the script, there's two things that you need to do. So number one, the file has to be executable and readable, right? Because you want to treat the script as though it were a command, right? If you want to treat it as though it were a command, it has to be executable, well, and readable, right? So at least for the user, it has to be readable and executable. But there's a second requirement that often confuses people new to Bash, right? And that is the operating system needs to know where the script is located, right? So in other words, you need to know, if you know the absolute path of the script, you can run the file by using the absolute path name. That's inconvenient, right? If you're in the current directory where the script is located, right, you still have to tell the operating system where is this command that you're trying to run, right? So the way that Linux determines where to look for commands is that there's a variable called the path. Right? So the path is just a list of directories where the operating system will look for any executable file. Right? The current directory is not part of the path. Right? So if you're in some directory somewhere, like this, right? So I'm in the Introduction to Bash Scripting directory. Right? Notice I've got a bunch of files here. They're all in green, so they're all executable. Right? So notice the execute bit is set on all of these. Right? And so these are all commands. Right? So I should be able to run any one of these commands. Right? So if I type in hello sh.sh to try to run that as a command, right, the shell complains. Right? It says, I don't know where this file is. Right? Well, it doesn't know because the shell is looking at this list of directories in the path for a file called, or for a command called hello.sh. Current directory is not part of the path. Right? So I have to tell the operating system where is this file. Right? The easiest way to tell it where is the file is to tell it the path name to the file. Right? So the full path name to this file is all of that, which I don't want to type in. Right? If you're in the current directory, you can just type /. Right? Remember what this is? This is a relative path. Right? Dot is the name of the current directory. Right? So // some command name, right, is the path to that command name. Right? And now I can run that command, which prints out hello world. Right? If I'm in the directory above this one, right? So now I'm in the scripts directory. Right? If I want to run that hello.sh file script as a command, right, I have to tell the operating system where is that file. Right? So that file is located in that directory. Right? Its name is hello.sh. Right? So to run the script, you need to tell the operating system where is that file. Right? unless you want to set the path variable or augment the path variable, you need to give it the path name to get to the file, right? Even if you're in the current directory, right? So again, even if I'm in the current directory, I have to type / to run the program, right? And don't forget, right? In order to run that program or that script as though it were a command, the user needs at least read and execute permission on that file. Okay, so how do I make that script called hello world? It looks like that. Right, so that's the contents of that script. How do you make that script? You just fire up a text editor and type that into your text editor. Right? So whatever text editor you want, it doesn't matter. Right? I'm going to use code, so I can use code. I'm going to make a different script called also hello. Let Visual Studio Code do its thing. It'll start up any second now. And still starting up. Okay, oh, sorry, right here. And I'll make that bigger so you can actually see it. Come on, there we go. Okay, so the contents of the script, the first line always starts off with hash bang, so hash bang, like that. Right, so in a Unix-like operating system, if the first line of the script is the hashtag followed by the exclamation mark, that tells the operating system that the rest of the line is going to be the name of a command that can interpret the contents of this file. Right? So in other words, I need to add the path name to the bash interpreter here. Right? Now in the lecture slides, it's bin bash. Sorry, in the notebooks, it's bin bash. Because I'm assuming you have a Linux environment. The problem is a lot of you are going to be using Mac, right? So for Mac users, it's user bin env bash like that, right? And so this is actually calling a different program called env, right? To use the bash shell as the interpreter for the rest of this script. This should also work on most of your Linux installations as well. So this should work for me as well, right? But the standard way to do this is the standard Linux way to do this is hashbang bin bash, right? Okay, so if you write that, that should work at least for the purposes of this course. Now what? Oh, so your script is just a bunch of commands. So you can put whatever command you want here, right? So I used echo before to print out the string hello world, like that. Right? That's the contents of my script. Right? So save that, whoop, like that. Go into your directory. Right? Where's also hello? There it is. Right? Can I run it? No, I can't run it. I don't have execute permission on it, right? If I try to, right, so I'm pressing the tab key, right, which should do auto-completion, but it will refuse to do the auto-completion, right, because it knows also hello doesn't have execute permission on it, right? If I force it by typing in that, right, it says permission denied. It doesn't tell you execute permission is denied, it just says permission is denied, which isn't super helpful, right? So make sure you have u plus x. Make sure you have execute permission on the file. Right? Now I have execute permission on the file, so now I can run it. So / also hello. Right? And now it prints out hello world. Okay, if I go back to my editor here. This thing here, right? This can be any that thing there is supposed to be the name of a program that can interpret the rest of the file, right? In this course, you're always using bash, right? But you can write any scripting language. You can write this in any scripting language that you want to, right? So for example, you can do the exact same thing with Python as well, right? So here, instead of using bash, right, I could use the Python interpreter instead, right? So I can make a Python script in the exact same way. Right? So here you'd put in the path to your Python interpreter. I'm not even sure it's on here, so hang on. I think it's Python 3. Okay, so user bin Python 3. Right, so if I wanted to, I can make a separate. So I'm going to copy also hello to also hello.py, and then I'm going to edit the Python script instead. Bloop. Okay, so I can change this to user bin Python 3. Right. I can change this to some Python code now. Like that. Right, and now I can run, hopefully, yes. So now I can run, that as a Python script, right? And now that works as well. Right? So as long as you know the direct or the path name to your interpreter, right, you can write a shell script. You can write any scripting, any scripted program, and have it run this way, right? Whether you're using Python or Bash, if you're on a Mac, you might be using the Z shell, or any one of the other various shells, or many scripting languages that there are available to you out there. Right, this hashbang thing will work for you no matter what. All right, so we've now got, you now know how to write a script. Right, so that's a very simple script. Right, if you need the instructions, hey, they're right there. Right, so they're in the notebook. This explains the hashbang thing. Oh, you can also, yes, I forgot about that. There's another way to run a script as well. Okay, so there is hello shell, hello, also hello.sh. So if I take away permission on that, so take away execute permission on my shell script, right? If I try to run it directly from the command line, that doesn't work anymore, right? It says permission denied, right? But I can explicitly run that script through Bash, just like you would explicitly run a script through your Python interpreter, right? So to run a Python program, you could type Python 3 also hello.py, right? And that also works. You can do the same thing with Bash, right? Bash sh, right? So even though I don't have execute permission on this file, right? Now I'm passing the file to the Bash interpreter directly, right? And so you can run it that way as well. Right, either way is fine for this course. The TAs will always turn on execute permission on your scripts when they go to mark them. Right. Okay, you can put whatever you want into the shell script. Right, so anything that the Bash interpreter will understand, you can put that into your script. Right, so there's a pipeline that runs fortune, pipes it to calce, and uses a moose to print out the contents of the file. I don't think this runs. Oh, it does run. Okay. So it turns out in Jupyter, you can run the script directly from the self. Right? So anything you want goes into any Bash code, any legal Bash code that you want goes into the script. Right? It runs the script line by line. Unless you have a function in the script, right? And then functions behave the same as functions in Python. Okay, so these examples don't really do anything interesting, right? Other than show you how to make a simple script. So here's a script that makes the start of a Bash shell script for you, and then saves the contents in the file temp.sh, right? And then turns on execute permission for you, so that all you have to do now is open up temp.sh and edit the file, right? And then you now have a runnable shell script. It's always temp.sh, which is inconvenient, but we'll fix that in a minute. Right, so how does this work? So I'm going to use echo to print out that string. Right? Notice what the string is. It's hashbang root bin bash. Right? Echo prints that to standard output, but we've redirected standard output so that instead the output goes to the file temp.sh. Right? So that creates the file temp.sh, and the first line reads hashbang bin bash. Right? The next command now changes the permissions on that file so that it's executable. Right, so there is no temp.sh here right now. Right? If I run, what's this called? This is called make.sh. Right? So if I run that script, right, I've now got a empty shell. I now have a file called temp.sh that's already executable. Right? If I look at the contents, it's just hash bang bin bash. Right? Now you can just edit this file. Right? And put in whatever you want. Right? So echo, for example, for egg. Right? And now you can run it like that. Right? So that's a tiny little script that creates the skeleton of a shell script for you. All right, do you have comments? Yes, you have comments. Right? What do they start with? They're exactly like the Python comments. Right? So it's the hashtag. Right? So the hashtag is the line-ending comment, just like it is in Python. Right? You can't use you cannot use Java's // right? That doesn't work. So anything that's a comment is simply ignored by the interpreter. Right? All right. So there is a program. Right? Starts out with hash bang bin bash, comment, space, comment. Right? It says this program does nothing almost. If I run it, nothing happens, which is good because there's no commands in there. Right? So when you run that thing there, it looks like it does nothing, but that's not true. Something does happen. So every command that you run in Unix produces what's called an exit status. Right? So you run this program. That program has an exit status. Right? The exit status gets set by the program when it exits. Right? Typically, if a program exits and there are no errors encountered, the exit status gets set to 0. Right? If something unusual has happened, the exit status will be not 0 and greater than 0. Right? So never negative in bash. Right? And so it actually sets what's called the exit status. So I'm going to go to my terminal and run that program. Right? So there is comment .sh. Right? There is no actual command in there. Right? If I run it though, right, I can print out the exit status because the exit status for the most recently run command is in a variable called question mark. Right? Notice that's weird, right? The variable here really is called question mark. Right? So bash uses symbols for some of its significant variables. Right? Question mark is one of them. It's the exit status of the most recent command. Right? It's a variable, I want its value, so I need to slap a $sign in front of it. Right? So $, get the value of question mark, the exit status of the program. Right? You'll see that it's 0 here. Right? So that program ran successfully. Here's an example of a program that doesn't run successfully. Right? So I'm going to use ls to list that file. That file doesn't exist. So ls runs, sees the file doesn't exist, outputs an error message. Right? Notice that its exit status is not 0, right? It's something else, right? So typically 0 means no error has occurred, right? For the exit status, any positive value, any non-zero positive value indicates that something unusual has happened. Right? All right, so that question mark is what's called a special parameter, right? So bash uses this strange terminology. If you see the word parameter in bash, the word parameter means it's a variable that doesn't start with a letter, right? So it's a symbol typically. Question mark is one of those, right? A parameter is just a variable. It just happens not to have. It just happens to not start with the name of with a letter, right? Variables always variables. The term variable in bash means that you've got a variable that starts with a letter. Right? So they're both variables, it's just that a parameter is typically named with a symbol. Right? You're going to see several of these as we go through the course. Okay. Anything else? Quoted or escaped? That's fine. Right. So comments, the bash comment always terminates the line that it's on. Right? So you cannot use the comment in the middle of a command somewhere, right? So here someone wants to list out all the files that, I guess there should be a star here. The intent here is to list all the files that that end with .txt. But the writer of the script has put in a hashtag here, right? So that hashtag starts a comment that ends the line. So all of that gets treated as a comment, right? So there's no splitting of a command with a comment in bash. Do I want to do this? I guess this is a good place to stop because this next part's going to take a little bit. So the next part tells you how to pass commands or command line arguments to your command and how to get those arguments in from inside the script. All right, we'll talk about that in the next lecture.